This video will explain to you the chain rule for derivative. If x is a function of time, xt, and y is also a function of time, y of t, are differentiable at time t. If z is a function of x and y at the point xy, then z also as a function of time in terms of f of xt and yt is differentiable at the time t, and dz dt is equal to partial differentiation of z with respect to x times dx dt plus partial differentiation of z with respect to y times dy dt, where the ordinary derivatives are evaluated at t and the partial derivatives are evaluated at xy. In terms of diagram, we can see this diagram here, z as a function of x and y. So you can partial differentiation of z with respect to x and partial differentiation of z with respect to y. X is a function of t. So you can do a normal differentiation of x with respect to t and a normal differentiation of y with respect to t. And the rate of change of z with respect to t is the sum of these two rate of change. Example 12 to illustrate the application of chain rule. Here, z is given as a function of x and y, which is equal to x squared y. And x is a function of time. So xt is equal to given by t squared, and yt is equal to t cubed. We are going to find the rate of change of z dz dt by chain rule. First, because z eventually is a function of time, so we can do dz dt. Because z depends on x and y, and x depends on t, and y depends on t. So eventually, z is a function of time. Therefore, we can find dz dt. To use the chain rule to find dz dt, first, we partial differentiation of z with respect to x first, which will give you 2xy, and partial differentiation of z with respect to y, you get x squared. And then x and y are function of time, so you can use a normal differentiation. Dx dt is 2t, and dy dt is 3t squared. To apply the chain rule, we know that dz dt is partial differentiation of z with respect to x and dx dt plus partial differentiation of z with respect to y times dy dt. Partial differentiation of z with respect to x is 2xy, and dx dt is equal to 2t. And partial differentiation of z with respect to y is x squared. So this is x squared now. And dy dt is equal to 3t squared. Now, Substitute the x and y. We know that x equal to t squared, so this is 2 times t squared, and y is t cubed. And multiply by 2t, and then x is t squared, so t squared and square again, and 3t squared. Then multiply them together. This is 2 times 2 is 4. 4 times t power 6 plus 3 times t power 6. You get 7 t power 6. This is part A. For part B, we are going to check the result in part A by expressing z as a function of t and differentiating directly. So first of all, z is x squared and y, but we know that x is t squared, so t squared square and y is t cubed. So this is actually t power 7. Therefore, when you find dz dt, this is equal to 7 t power 6 as we found out in part A.